Hello, everyone that are listening right now, and welcome, and of course, everyone that is listening, after the fact. Today, I will talk about global digital twinning, and of course, my name is Nicholas Werner. I work as a digital twin specialist here at Winio, and also as a interim CSO at EDX Technologies, where everything is, of course, about global digital twinning. Well, not everything. It's also about 6D simulation for infrastructure orchestration, specifically in the telecom industry. And I think that's something that I also will touch upon because I think, everything or whenever you talk about digital twins, you have to talk about simulation capabilities. So let's start with, and I hope that, we'll get a lot of comments here. If that's not the case, then I hope you will join it anyway. So let's start off with digital twins. So what are they? And why are they necessary? So there are a lot of different definitions. The one that I usually use is a digital representation of something that exists in reality, fed with real-time data at certain intervals, so-called twinning rates. That is sort of like the stereotypic version, I guess. Then of course you have prototype digital twins that maybe it doesn't even exist yet in the real world. So you want to create a prototype of something that might turn into a digital twin once you fed that 3D model with real-time data. Or maybe you want to have, let's say, a simulation digital twin where you want to do simulations and all this kind of stuff. And that might not also, be for something that exists in the real world, but you want to try it out first and you want to take something to market. And a good example right now is, when they're building stuff for the Mars rover and these cool things like that, you basically mimic everything in the software space, so to say, even the hardware, because there's a hardware supply crunch right now, so that you simulate everything, you build up like virtual models of the hardware, the Ethernet cables, and everything there, and you simulate how the code would behave on top of the hardware simulations, the test benches. So that's also an interesting thing because then the traditional way of phrasing digital twins is not it doesn't exist yet in reality. But I want to go with something, simpler or something that is not as technical, perhaps. So just imagine, again, so we're going to start with, sorry, I just got an email. We're going to start with, what are the benefits with digital twins? Why is it a difference between existing modus operandi and basically any industry? And I think like the main difference is that, let's say you have a problem in a factory or in a city, or let's take a factory, for instance, and you want to get someone to solve that problem. And of course, it's not a problem with the whole factory or the whole supply chain at once. It's a part of the factory. It can be a machine that breaks down, or it's a problem with the processes, or whatever it might be. It's a part of something. So you invite someone that is an expert in that field, and you try to explain that to that person. And at the same time, of course, everything around that machine changes, right? All the other machines, the supply chain, the different processes, the people might change, and it might take a while for you to find out, what are the problems, how are you going to explain it to that person, and what happens if we fix this problem, how will it affect everything else? So, like in any business, there's a lot of things going on, to put it mildly, and you want to know, okay, how does this change that we do here, how will that affect everything else? And of course you want to know that preferably beforehand, but since everything is a moving target, it becomes a problem because maybe you get all your information in order, you get the PowerPoints, you get the PDFs, the Excel sheets from that specific point in time, but it's not in real time. It's taking data that historically this has happened, and then you try to understand how is this affecting us right now, and then every time you do this, everything else changes as well. So I think like that is the main benefit, I would say, with digital twinning, that not. I'm back now. Sorry, Damien tried to call me just now. It didn't. I hope this works again. Sorry for the interruption, everyone. So again, the immediate benefit, I would say, with digital twins is not only for that machine, because even if you get real-time understanding, how that machine is operating, of course you have no idea about the context, which is also a little bit of the tricky part, that you have to know everything, and context is of course a really really big factor when you're dealing with digital twins or any kind of initiative. You have to understand what's going on, not with that very thing, but all around it. So again, having a digital twin that gives you access to information, and hopefully understandable information in real time, is often what companies are lacking. Just understanding what their reality is doing at any given moment, especially this moment. Because that's a lot of that's something that not a lot of companies can ask or answer, and especially not across different domains. So again, if you have a top view of a factory production line or even a city, the benefits of utilizing maybe game engine technology like Unity or Real Engine, or at least something that provides a very good visual understanding that represents reality in a pretty good way, and not necessarily cartoonish, it depends on what level, but actually representing reality the way that it looks like, it's just in a digital way. And if you feed this with real-time data, it has the benefit of explaining something that can be understood and also be explained across domains, across the different people that are in this factory. The IT people, the OT, operations technology, the information technology, security experts, the decision makers, management, the boots on the ground, maybe the ones that want to supply machines there. All of them can get real-time insight into what is happening in that space right now, and everyone can actually understand that. And that's usually not the case when you're working with the tools over time or past time, because if you want to show something in an OT kind of setting to someone that works with IT, or someone that works in sales or marketing, or anything except for understanding that lingo, the acronyms, and also possibly the data, you can't do it, right? It's really like, hey, can you look at my screen and understand what I'm saying here? What we're going to do with these MES systems. I don't understand what you do. I mean, I work over here, and that's a completely different systems, completely different programs, completely different everything. So that's again like the benefit of having collaboration between different people in a shared reality that also is updated in real time. That's a huge benefit that shouldn't be taken lightly. So why am I telling you this when it's going to be about global digital twinning? It's because it's just the same, it's just a little bit larger. So if we then zoom out from that city or from that factory, and zoom out to a global level, what are we going to see? Well, of course, we're going to see, the planet maybe spinning around. We're going to see all the different, countries, how blue this planet is, and all this kind of stuff, right? We're also going to see that, we have a lot of different cultures, a lot of different languages. But to be honest, it's more or less, all the same, just different. So I was in a call the other day because I'm an advisor for a 3D printing company, and we're looking at, some countries, specific countries, let's say in Africa, for instance, right? And for EDX technologies, the what we do is plan for wireless planning for telecom infrastructure. So 4G planning, 5G planning, and I know some people in the audience that's gonna love this. Also 6G planning, right? That's definitely far off. But let's say 4G and 5G planning, that's sort of our bread and butter, and through the global digital twin perspective. So let's say you have then a country, let's say Nigeria, for instance, because I've been working a lot in Nigeria in the last 10 years. And we want to get an asset situation of, let's say, again, like the telecommunication infrastructure and also the radio propagation. How good connectivity do we actually have in Nigeria at what places? And let's look at Lagos, for instance. I think it's the biggest city. It's not the capital, but it is the biggest city. So then just imagine, you look at, Google Earth or our digital twin, Earth platform that we have as well. And you look at the world, and then you zoom in to whatever city in the world. It could be Rio de Janeiro, could be here in Gothenburg, in Austin, Texas, or again, like in let's say in Lagos. So you zoom into Lagos, and you see sort of, what it's all about, the topology. You don't necessarily know if it's been updated for quite some time. That's usually the case with a lot of these, different map companies, that it is not updated. And the maps that you buy, they're very, very static, and it proves, it provides a part of a reality that is usually obsolete at the moment of purchase, right? So you want to get, again, like a digital twin perspective of that city. What's happening in real time, maybe mobility patterns. You want to get pollution in. You want to get all these fragmented data sources that are happening in different systems at some point, or it actually might be the fact that they're not happening. But you want to get a real-time understanding of what goes on, again, from a factory or from Legos. So from a telco perspective, we want to say, okay, what is this as this situation of the telecom infrastructure? So it starts with a subscription digital twin where EDX technologies can keep these maps updated. That's a big difference from the standard modus operandi where you buy a map once and then you do something with it, then you want to do something else, you have to buy a map over and over again. The providing the ability to provide subscription digital twinning is really interesting because it keeps it up to date, that part of the world, in a 3D kind of perspective, right? So you build up a 3D perspective where all the trees are, where all the buildings are, the infrastructure, all this kind of stuff, because that's what you need in order to plan for 4G, 5G, for the next generation of telecom infrastructure, the connectivity part. Because if you don't know what's going on in that space, you can't plan it, right? But if you do know exactly what's going on, that's when you can use simulation engines like the one that EDX technologies have. I understand this is more of a sales car, but it's sort of like it sounds like that. It's not. The simulation capabilities of digital twinning is what fascinates me, I would say, the most, and it has been fascinating me the most about digital twins, but it's not talked about that much, right? Because you stare about what is the digital twin, not necessarily what capabilities it can deliver, it should deliver at different stages. So again, we build up a 3D virtual space. This could be of a factory, this could be of a country, this could be a part of a country, like again, Lagos in Nigeria. So you're looking at like a virtual world where everything is in 3D, you see everything, the trees, all this kind of stuff. And then once you have that, you also fill it with information about the existing wireless planning, the wireless network. So you can see the as-is situation. You do measurements, maybe you deploy sensors, you can actually measure this in real time continuously. So you get an up-to-date picture of the existing dynamic status of the wireless network in that city. And then let's say you say, okay, we have, let's say, 46% or 56% coverage in the in this area that is deemed to be like Lagos. And then the question would be, okay, we want to get to 100%, right? Or we want to get to as close to 100% as possible. How do we do this? Well, you can of course try out stuff, and you sit with Excel sheets or GIS data or maps or PDFs or whatever kind of planning tools that you have at your disposal, and you go out and you do measurements and all this kind of stuff. But that takes quite a lot of time. But if you have, again, like the as-is situation of the wireless network, and you also have an as-is situation in 3D of the existing lay of the land in Lagos, then what you can do with the 6D simulation engine is that you can ask the digital twin, where should we place the cell towers to get to 100%, right? And then the engine starts understanding, okay, this is what we have right now, this is what we have to play with. In order to get the full coverage in this area, we need to place cell towers here, 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 and here, and they need to be equipped with these kind of cabling, and they have to be like at this size, and it sort of automates all this kind of stuff down to the buildings, the bill of materials, the cost, the size, the cabling, and all that comes with it. And it's okay, if you do this, you'll get to 92%, 96%, 99%, something like that, right? And then the cool stuff about this is that now you made the digital twin do the job for you, right? You filled it with input data, and then you asked it for the best path, as well as based on the outcome that you want to reach. And that's again like how you move from data to information, information to insight, insight to action, and action to impact. You actually turn it around. So the impact that we're asking for is 100% connectivity, or as close to it as possible. The actions that we need to take is what the digital twin tells us to do. And here comes an interesting perspective, I think, where EDX Technologies has, fantastic platform. Because if you use just the tools that, are in the telecom industry, I wouldn't get it, right? I worked, of course, with, you know, from a high level, a lot of it, self-driving cars. I know about some of the aspects of 4G, 5G, but it's not nearly close to what the experts know that have been working in this industry for a long, long time. And it's the same with everything, with AI, IoT, energy, all these kind of things, right? There are so many different experts that are geniuses at what they do, but sometimes, I would say most of the time, they don't have the ability to translate what they know into something that someone else can understand unless they're at their level of expertise. Here's where augmented reality, virtual reality, visual ways of working, let's say, whatever that might be, comes really, really handy. So again, the digital twin is telling us, what to do, how to get this done, not just like, the data to information, but actually how to get to the impact and what actions to take. But the important thing here is that how is this digital twin displaying this information to me? And that's where it becomes extremely interesting, because the way that EDX technologies work is that they can display this in real time in augmented reality as well as virtual reality. So basically, we can be here instead of this, LinkedIn Live that is done at this, video conversation that is not a conversation, it's just a monologue at this point. It's that where you can actually see this, if you look up into the sky, right? You imagine you're there either in Lagos or wherever you are right now, and you zoom into this map. So if you're not in Lagos, you can see this, appear on the sky basically, right? You can see these cell towers automatically sort of populating, and I'm exaggerating a little bit, but that's exactly how the engine works. You can see this, populating the bill of materials, what the cell towers are going to be, and where they're going to be in the city to reach 100% or as close to 100% coverage. And seeing is definitely, maybe not always, but definitely believing, right? So if you can see this, and it's the same thing if you're in Lagos, you look up to the sky, you can see the ASIS, sort of like wireless coverage. You can see the gaps where they are, and you can basically see, cell towers being dropped down from the sky, boom, 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 throughout the city. When Mitch Bale, very interesting, my field automotive, definitely. So everything when it comes to infrastructure planning, charging electric infrastructure, whatever it has to be, the hospitals, anything is really, really cool, because this is how we should do, because we know the SS, even though it's fragmented. Anyway, I got sidetracked. That's because of you, Vamid. Shame on you. I'm just kidding. Fantastic comment. But so again, you look up into the sky, and the digital twin tells you what to do, and it shows you what to do, right? It doesn't just tell you, it shows you. So you get all these cell towers like boom, 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 right? Across the city. This is where they're gonna be, okay? Fully automated with, what the cabling is gonna be, all this kind of stuff, what they're gonna cost you, all this kind of stuff. And then maybe you say, okay, maybe we wanna change this over here. Or let's say, okay, oh shit, we didn't account for the new, high-rise buildings is gonna be here, or there's a bunch of trees here that we forgot to feed into the model. Okay, let's get them into the model, and then the digital twin dynamically recalculates how to get there. And I think that is, again, you want the modern tools and technology to work for you, and to be able to explain that to you, but not only to you as an expert, but also to the ones that are going to buy this stuff, right? So the users, so the people in the city, the politicians, the not so domain experts, because again, there are so many people involved here, and the only thing that we can agree on, most of us at least, is reality, right? Or we can at least have an argument starting with that reality. So again, this is what we do. So EDX Technology is the number one, simulation, wireless planning simulation tool in the US. And my job is, of course, to help them scale, not only in telecom industry, but also through other areas. Because I believe that this is how we should use modern tools and technology, right? To help us make informed decisions, to simulate the future so that we can transcend the now, not just limited to telco infrastructure, but again, with everything. Because if you have a real-time dynamic digital twin of a city, a factory, a country event, or whatever that might be, you can ask it, and it will tell you where should we do all this kind of stuff, right? And if you have, I need to wrap this up. I love this so much, you wouldn't believe. I'm working, with systemic change across, the whole of Africa. We want to, scale this up. We have discussions in basically any and all continents in the world. And this is something that shouldn't be limited just to telecom planning or wireless planning. This can be and will be also tailored to infrastructure planning, orchestration, life cycle orchestration, because again, when you have a digital twin and you introduce new data to it and it re-dynamically recalculates, that is the very definition of digital twinning. And if you can also to use it from creating prototypes and saying like this is how it should be, utilizing that to make it real in the real world, and then having it updated with IoT forever, and then you can also use that and store that information forever, so it becomes more like a circular economy where all the data that has been generated at any point in given time can be turned into information, sorry, that leads to insight, action, as well as impact forever. So with that said, I'd love to show you or anyone that is listening, this tool at some point in time. If you have any questions about, of course, digital twinning, about augmented reality, virtual reality, or basically anything, I think that I definitely would love to have the opportunity to answer those questions, or I'll point you to someone in my extensive network that definitely can possibly answer those even better than I can, that is a subject matter expert in maybe something else that I'm not the subject matter expert in. But if there's anything about digital twins or maybe global digital twinning, there's definitely a lot more to discuss that I haven't even touched upon here. So thank you so much for this call. We have actually a question here that I didn't see. We have a couple of questions. So just one more minute. I can't help myself. Okay. Digital twin for autonomous application in medical areas. Yeah, I've been working quite a lot. Well, that is an exaggeration. I've been working some with healthcare the last 2 to 3 years, both as an advisor for a great startup scale up, ReadyMinds in the US. So I think like Madhu Redibona, if you are either listening or if you can find him in my connections, or I can introduce it to him, he can definitely answer this much more in terms of digital twinning. And also from ANSYS, Mark Horner is also a great person to talk to. But what I know about digital twins for autonomous application in medical areas is that, again, you want to work with physics-based simulation tools, depending on what area, of course, you're talking about. It might be for the Industry 4.0 side, which I know sort of how to do it as well. But I think like in medical areas, it's a bit too broad. So I think it depends. But I think like, tools like if you search for ANSYS, they have a great tool set to work with. And I know that they do a lot in the medical areas, definitely for autonomous applications, depending on what stage. They are a lot focusing on prototype digital twins, where you can also use other tools to make it into like the existing digital twin areas. And even ANSYS has a digital twin. I think they call it the digital twin maker, if I'm not mistaken, which actually I think I am. But just search for ANSYS, and again, like just reach out to me directly, and I can definitely put you in touch with the right people. Would you describe an example in fintech for digital twinning? I think there are a lot of them in the background that goes on, and I think that Piano is one that I think is really, really cool. Not necessarily fintech though, when to think about it. I have to, I think, like get back to you on the digital twinning and fintech, to be honest, and to come up with some concrete examples. We're working on some aspects related to having more transaction through digital twinning, virtual ownership, and that's also something that we discussed in the Digital Twin Consortium, which is really, really important, because when you have real-time data, in any information from fragmented data sources, there are a lot of opportunities of solidifying them, creating a holistic perspective, even creating NFT strategies around this topic. And one company actually that I probably should mention, which are doing this, digital twinning to some extent, but definitely NFT enablement and platform enablement, is actually Black Buffalo. Black Buffalo. You can find them on my LinkedIn, where I am an advisor. It's not exactly the Black Buffalo themselves that specialize in 3D printing, but it's their sister company, Flash Labs, that have created an NFT platform where you can combine this with IoT data and possibly do stuff in fintech that is related to digital twinning. That said, there are probably a lot of other use cases. We have more information that gets updated in real time, and you tie that to transactional ways of working. I can't come up with something that is stellar right now, and I really need to go. So I'll have to do that the next time. But thank you so much for listening. And again, if you have any questions or comments about anything related to digital twins, even 4G, 5G planning, AR, VR, or anything about the future, let me know. If I don't know about it, I would love to get those questions so that I can learn more about it. And if I know about it, I'd love to share that with you. So thank you so much for listening right now. And also thank you for checking in afterwards. Take care. Bye-bye.